Oh, what a day! What a lovely day!
Welcome to Science versus Scientism. I'm your host, Nathan Oakley, and joining me this evening is YouTuber Quantum Eraser. How you doing, John? Good to have you.
Doing fine, sir. Thanks for having me again.
Pleasure, as always. Do you want to jump straight into it? Should I share your screen immediately?
Yeah, go ahead. You can go ahead and share.
Okay,
Tell me when it's up.
Yeah, you're up.
Yeah, I've been out of the net for a week or two, and I've been trying to catch up, just trying to catch up with what's been going on. And obviously, you already know what's going on because you've been there. And all I've been hearing is Cavendish gravity and this gas pressure thing again. I mean, I just did this presentation on your channel, like, I don't know, a week, 2 weeks ago. And I thought it was pretty comprehensive. Apparently not, because the biggest thing I had with the gas pressure was people bringing up gas pressure gradients, right? I told you, I even explained it. Don't do that, globetards. Don't do that because you're not answering the question. And then I'm going through a video. Guess what I hear? First thing, gas pressure gradients. Unbelievable. You got mud in your eyes. Or is the cognitive dissonance mud? Is that a special kind? I don't know. We're going to go through it again here in a couple minutes. Maybe it'll take, I don't know. I don't think so. But let's go ahead and start off with gravity. And we're going to go with Cavendish and Newtonian gravity. Just briefly hit on Einsteinian. That's not the point because everyone's talking about Cavendish. Cavendish this and Cavendish that, right? So let's go ahead and read through this because I can end this Newtonian gravity buffoonery quick. You see, your pseudoscientific community, whoever or wherever they are, doesn't even follow Newtonian gravity. So why are you bringing it up? I mean, I can understand you parroting certain things, right? But you're parroting nonsense. Let's review this very slowly, okay? This is from George Musser, and it's from Scientific American, November 2015, right? Let's read through this slowly. Einstein created his general theory of relativity, which provides our modern understanding of gravity, okay? He's providing our modern understanding of gravity. Einstein, general relativity, with the express purpose of expunging non-locality from physics, okay? Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two. Now, what did he snap? What is he speaking to here? Well, he's speaking about the magic wand he previously mentioned. And general relativity snapped the wand in two. That means he broke it by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. Okay? This is pretty self-explanatory. I mean, I don't know what to do. Let's go through it step by step. So, what George is doing up here, right? He's creating a juxtaposition between Newton's gravity and Einstein's gravity. It's a dichotomy. This is plainly seen by this citation. Newton's gravity, that's a force, acted as if by what? Magic, right? That's what he said. You see the magic right here. Okay? Einstein's gravity then snapped the wand in two. Well, which wand? Well, Newton's magic wand. He snapped that in two. That means he broke it. Number 4, what gives rise to gravity? Well, the curvature of space-time. He just set it up here, right? The curvature of space-time. What doesn't give rise to gravity? Well, Newton's invisible force, right? He just said, not an invisible force gives rise to gravitational attraction. Now, are there any questions? I don't know if I can break this down any further. So, Nathan, did I
Yes.
miss anything here? Should I
No,
add anything?
no, I don't think you can. It seems pretty self-explanatory.
Okay, let's move on from this one. So, some, and it's very few, but some catch on to this, right? That they're two different things, Newtonian gravity and Einsteinian gravity. Some eventually realize that it's nonsensical buffoonery. And guess what they do? They then say Einstein's train wreck, that's general relativity, explains Newton's law, right? Okay, listen closely. The real scientific theories never, ever, ever explain laws. Ever. They're two different things. Okay? Newtonian gravity and Einsteinian gravity are mutually exclusive. Newtonian gravity is a force. Einsteinian gravity is not a force. Okay? You can go ahead and look it up. If you need a citation, just ask me and I'm going to go ahead and bring that up too. I'm not going to do it here for the 12,675th time. Number 3, they're not even in the same geometry, for crying out loud. Newtonian gravity is Euclidean 3 space, whereas Einsteinian gravity is pseudo-Riemannian 4 space. Number 4, Newtonian gravity is instantaneous actions at a distance. Einsteinian gravity is limited to the speed of light. All right? I couldn't purposely get two things any different. Beach balls and Bunsen burners have more in common than Newton's and Einstein's fairy tale. Either of their fairy tales. We're dealing specifically with Newton's here. All right? But Einstein's is equally a fairy tale. We may get to that detailed presentation at some point. Is there any questions right here about the mutual exclusivity of this?
No,
Nathan, anything that I missed?
No, one's not a force and one is a force.
Yes, that I could end it with either of these. I could stop right here and say, okay, I'm done. I could stop right here and say, okay, I'm done. And I could do it with number 4. Okay, I'm done. I can prove it right there with that. I've given you all of them. Okay? So here we go with this mass attracting mass. This is one thing that popped out. So the alleged hypothesis, right? Larger masses attract smaller masses. Now, I'm going to give you the benefit of the doubt here and give you the independent variable, which it's not, but I'm going to do it anyway. So the independent variable here with this alleged hypothesis is mass, right? The dependent variable is attraction between masses. Listen, this thing right here is not a scientific hypothesis. It's not viable, or it's not a viable independent variable either here. Masses attracting masses is an effect, not a cause. Mass itself is a concept. It can't even be defined. I'm going to show you that here towards the end. If I forget about that, Nathan, go ahead and remind me about that one. We'll check this definition. It cannot be and does not cause anything. Mass doesn't cause anything. And you don't observe mass in nature, right? Unless you got Superman X-ray eyes. This right here is the actual hypothesis that these people are trying to put forward or postulate. They're just not saying it, right? If gravity exists, then larger masses will attract smaller masses, right? This right here is a fallacy. This isn't affirming the consequent, and it's a formal logical fallacy. They all take this form. If P, then Q. Q, therefore P. So let's put it in here, right? If gravity exists, P, larger masses attract smaller masses, Q. We observe larger masses attracting smaller masses, Q, therefore gravity, therefore P, right? It's just this cut and dry. The logical fallacy is that P doesn't necessarily follow from Q. For example, if I had just eaten a whole pizza, P, I would feel very full, Q. I feel very full, Q. Therefore, I have just eaten a whole pizza, therefore P. This is train wreck, right? A child can see this because I could have eaten a 20-ounce ribeye with fries or the old 96er or thousands of other things to get full, right? Validate P, that is your gravity first. You need to validate this first if it's going to be in your hypothesis, right? It needs to be validated. You just can't dream up stuff. If unicorns exist, larger masses attract smaller. I could do the same thing. It's preposterous, people. So validate P or gravity first. Here's another. Somebody asked this quite. I couldn't believe it. Give an example of a scientific hypothesis that doesn't affirm the consequent, right? Wow, that was real tricky for me. I was slaving over trying to find one. Here it is. If vitamin C intake is crucial to collagen integrity, then eliminating vitamin C intake will cause scurvy. You see this? This is not an affirming the consequent form of logical fallacy. Why? I didn't conjure vitamin C, right? I didn't conjure P. It exists. It's my presumed cause. And I can vary and manipulate it, right? Or test it in an experiment. The whole point of a hypothesis. By the way, vitamin C is the presumed cause. But vitamin C isn't a presumption. Do you get it? Does this make sense to people? Let's spend a little time here. Vitamin C is the presumed cause, but it in itself, vitamin C isn't a presumption. I don't presume vitamin C. I mean, vitamin C exists, right? I'm sure I got a bottle of it out there somewhere, probably in the dustbin. Vitamin C exists. Whereas gravity, it's not physical, for one. It doesn't exist, and people just conjured it, right? So it's an affirming the consequent formological fallacy given this hypothesis, and that's your hypothesis. All right? This is a pretty important one right here. If you can get this, it'll solve a lot of problems, maybe limit some confusion. By the way, the person who asked this, give an example of a scientific hypothesis that doesn't affirm the consequent, you'd fail 5th grade general science. Just letting you know.
Okay, so why is the concept of mass not viable as an independent variable?
Well, number one, Matt, you can't, if you're going to observe a phenomenon, right, you can't see mass. That's the biggest problem, right? I mean, you have to have X-ray eyes. I mean, I don't know. I don't know any other way to explain that. And mass, see, when you have mass attracting mass, that's not a hypothesis. See, that's an effect, right? You still need the cause for that. The people are skipping the entire question. They're just making a statement, right? So you need a cause. You need why. That's the whole reason why we're doing this. We're trying to answer the why question, right? The why is always answered by the cause. So I don't think I could break that down any further. Does that make sense?
Yeah.
All right. So another death knell, and we went over this one before, probably a few weeks ago. It might have been a couple months ago. So it's been stated on this channel, along with thousands of other channels. We're back to this mass attracting mass thing again. Okay. I already showed you why it's nonsense. It's an effect. You haven't answered any questions, right? You can put it in affirming the consequent form of logical fallacy. Let's have, one of their respected pseudoscience priests give his take, right? This is from Princeton. So, like I said, mass attracting mass is the cause of gravity. Everyone states that. So, Martin Rees, astronomer royal, esteemed British cosmologist. He's a homeboy for you, Nathan, an astrophysicist. Okay, what do he has to say here? Let's take a look at this. What causes gravity and mass? These questions still baffle all of us. Why is Martin Rees still baffled? If you're going around saying that mass attracting mass causes gravity, I mean, Martin, somebody didn't give him the memo, right? According to Professor Rees, does mass attracting mass cause gravity? Nope. According to Professor Rees, and we're not even going to talk about Einstein today, but might as well, put him in here. Does space-time cause gravity? Nope. He must have missed that class. Professor Rees must have missed that class. Somebody ought to email him and tell him, get your act together here. We know mass attracting mass causes gravity. Stop what you're smoking, Professor Rees. Therefore, gravity is merely a conjured term that describes an effect. That's all it is, right? It's not a cause. I could call it ducal Slopogerts. It still works. You're just conjuring gravity. Now, when anyone conjures or states gravity, they're immediately invoking a cause, whether they know it or not. It's either Newtonian gravity or Einsteinian gravity. It's either door number 1 or door number 2. Either door you pick, I'm going to jacket yard, just to let you know. Okay? Oh, and here's it. Yeah, remember I told you that mass couldn't be defined? Check this out. It's from Edwin Taylor and Professor John Wheeler, Space-Time Physics. Okay, what is mass? Let's see what they have to say. Nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count the number of atoms or by any other counting method try to evaluate the amount of matter, here's the punchline, that number would not equal mass. They can't even define it. So why can't you use mass as an independent variable? Well, you have to be able to at least define something for an independent variable. How about that? I'll just rest my case right there.
I'm good with ending it there, unless you've got something else you need to add.
Nah, that's it for the gravity. I think I covered everything. Yeah, I don't know, man. Something new will come out tomorrow. Some kind of
definitely. It's let's move on to pressure.
All right, here we go again. This was, like I said, 2 days after I got introduced to flat Earth. I've been saying this ever since that day. I'm still saying it. I still get the same rebuttal every single time. And then what did I hear this week? Well, gas pressure gradients. Oh my God. So listen up again. I'm going to go through this relatively slowly. The question is, how do you have a gas pressure, that's atmospheric pressure, without a container to begin with, right? When the pressure of a gas is the force that the gas exerts on the walls of its container. That's the definition of gas pressure, okay? To have gas pressure, it's got to be contained in this definition with a container. Let's go through a few of these because this container, I know it's running rampant throughout this genre that people are just getting out. It doesn't need a container. Gas pressure doesn't need a container. What are you talking about? Okay. Kinetic molecular theory explanation of Boyle's gas law. Here we go again. Observations about pressure may be explained using the following ideas. The rapid motion and collision of molecules with the walls of the container causes, that's a key word, pressure. What causes it? Well, the rapid motion and collision of molecules within the walls of the container causes pressure. Well, if I take one of these conditions out of here, right, do I have gas pressure? No. Pressure is proportional to the number of molecular collisions and the force of the collisions in a particular area. The more collisions of gas molecules walls, with the walls of what? Well, the container, the higher the pressure. So, tech target. A gas is a sample of matter that conforms to the shape of a container in which it is held and it acquires a uniform density inside the container. This is a really important point. Even in the presence of gravity, even if fairy tale gravity existed, either one, Newtonian or Einsteinian, even in that presence, and regardless of the amount of substance in the container, if not confined to a container, what's going to happen? Even with gravity present, gaseous matter, also known as vapor, will disperse into space. It's called increasing entropy. It's called the entropic force. It's called the second law of thermodynamics. Okay? Gravity has no effect, even if it existed, would have no effect on it. None. Zero. From science.learn.org. The atoms and molecules in gases are much more spread out than in solids or liquids. We're going to talk about this here in a moment, right? They vibrate and move freely at high speeds. A gas will fill any container, but if the container is not sealed, the gas will escape. I mean, this is pretty cut and dry. From the University of North Carolina, gases behave differently from the other two commonly studied states of matter, solids and liquids. So, solids and liquids and gases are not the same. So we have different methods for treating and understanding how gases behave under certain conditions. Why? Well, because they're different. Gases, unlike, it's a big word right there, unlike, that means it's not like solids and liquids, right? Have neither fixed volume or shape. They are molded entirely by the container in which they are held. From NASA, the molecules are in constant random motion and frequently collide with each other and with what? The walls of a container. Because the molecules are in motion, a gas will expand to fill the container. It's expanding. It's trying to increase entropy to the maximum. Since density is defined to be the mass divided by the volume, density depends directly on the size of the container in which a fixed mass of gas is confined. I don't know. This can't get any more simpler. I mean, incoherent third graders can reconcile this. So this is tutoring for children. Like I said before, if you go to this website here, it has a special needs section and one for ADHD. All right. So if you need that, go there. This is what they have to say about a gas. It has no shape or size of its own. It takes the shape of its container it occupies the space given to it. Now, I just gave you 7 citations, 17 sentences. 15 of those sentences had container in it. I don't know. Probably not important. They probably just put that in there as filler. So, what do I get? Right? From the Globetards. Gas pressure gradients, right? This is the first thing that comes out of their mouth. Right? It's like Pavlov's dog. Gas pressure gradient. Before you can fallaciously appeal to a gas pressure gradient, that is a consequence, you must first answer where you got gas pressure without a container to begin with. Right? Essentially, you must show a tire pressure that's gas pressure without the friggin' tire. Right? Let's try this one. Maybe this will help. Which comes first? Number 1, gas pressure, or number 2, gas pressure gradient? Which comes first? Okay, I'm just going to leave that out there. Let it float out there. I
Number
don't
one.
know. Maybe
Number
we can
one.
bring up to the slobber nurses, right? Bring the slobber nurses in, and then we'll ask them this question. My word. I'll tell you what. Let's go ahead and meet Ryan again, right? We met him a couple weeks ago. Let's meet Ryan. What's Ryan doing here, right? Ryan's creating gas pressure, air pressure in his tire so he can ride his bike. But no, 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 no. See, if you're a globetard, you have to stop. If you see Ryan doing this, you have to stop him and ask him what his 7-year-old science denier is doing with the container, right? You have to rebuke him and tell him to get rid of that container because he doesn't need one to create gas pressure. That's how preposterous this is. This is the point that we're at right here, right? Next block of instruction, how to turn a doorknob with a light on. There's a special condition there. Any questions with this? Nathan, I can't break, I'm serious, I can't break this down any further.
Yeah, when you've got globe heads that are saying you get a certain PSI next to a vacuum, and you kind of scratch your head and think, so it's creating a pressure per inch on nothing. So the per inch bit you're just going to ignore in your measurement, right?
Yeah, pounds per square inch. Yeah, I don't know if it's preposterous. I I think I gave many reasons why. It's just not going to happen. You need a container. Ryan knows this, right? Ryan's got this covered. So, I didn't conclude. I'm sorry. In conclusion, let me conclude this one up. For the 57,896th time, this is the question. Okay. How do you have gas pressure, atmospheric pressure, without a container to begin with? That's the question, right? This right here is not the friggin' answer, right? Number one, it's a question. It's a question mark. Answers don't have question marks. But what about gas pressure gradients? I don't care about that. That's not my question. This is a begging the question fallacy via a red herring. Right? That's all it is. Answer my question, please. Answer this question. You answer this question, I'll be more than happy. Like I said, I have the answer to gas pressure gradients within a container. I got the answer for it. I'll give it to you. I'll be more than happy to give it to you. I'll be happier than a duck on a June bug to share it with everyone. But you must first answer where you got gas pressure without a container to begin with. This is an easy question. Cut and dry. P.S. Do not define pressure. If they have you define pressure, don't do it. Have the spinning ball tard, space monkey, religious zealots define gas pressure. Not pressure, gas pressure. Gas pressure is the topic. We're not talking about shark bite pressure here, right? Or crocodile bite pressure. We're talking about gas pressure. Conceptually, yes, pressure is the same thing, but there's some nuances to gas pressure. Let's get specific, okay? Sharks and crocodiles aren't gases. PS number 2, comparing water pressure to gas pressure is a false equivalence fallacy. Why? Even though liquids, that's water, and gases are arbitrarily classified as fluids, liquids are not gases, okay? Liquids are not gases. I know it's profound. Hopefully everyone got that. Water pressure still requires a container, right? If you have water pressure, you have to have a container. It does not have to be sealed, though, this container, because water is made of H2O molecules that have intermolecular bonds. They're called hydrogen bonds. That is, they don't move freely at high speeds, right? That's why the container doesn't have to be sealed. You still have a container. The ocean has a container, right? It has walls. It has a floor. It's still a container. It's just not sealed. Gases, however, need the container to be sealed because gases do not have intermolecular bonds. That is, they do move freely at high speeds, and they will escape. If the container is not sealed, you see, back to this again from sciencelearn.org. The atoms and molecules in gases are much more spread out than in solids or liquids. They vibrate and move freely at high speeds. A gas will fill any container, but if the container is not sealed, the gas will escape, and we'll finish it up with University of North Carolina. Gases behave differently from the other two commonly studied states of matter, solids and liquids. So we have different methods for treating and understanding how gases behave under certain conditions. Gases, unlike solids and liquids, there's that unlike again, right? They're not like, they're unlike, have neither fixed volume nor shape. They are molded entirely by the container in which they are held. Now, I know what's going to happen. I'm going to Mystic Meg predict this one. During the next 2 shows, or 3 or 4 shows, somebody's going to come in here and bring up gas pressure gradients. I already know it. They've been doing it for 3 years. Even after I tell them, I explain it. Doesn't help. Gas pressure gradients. I don't know what to do here. I don't. I don't know where to go from here, except to expose you. That's what I'm going to do. I'm just going to expose you and then just move right along, because there's no sense in talking to you, right? All right.
Excellent.
That's all I got for today, Nathan, unless you want to bring something else up that I missed.
No, I'm absolutely happy with that. I mean, like you say, it comes up frequently, but we had the conversation just before we went live to say that, yeah, it's about repeating things. Unfortunately, there are people that have thick heads, and you have to say the same thing many times for them to get what you're saying.
Yeah, and that's true. And maybe we can use this, because these subjects are going to come up again. I don't know. Maybe we could keep this as some type of shorts, right? Like gravity short or Coriolis effect short or whatever, and just make small little presentations. And then when anyone brings this up, because it's a rinse and repeat type of thing, right?
Right.
Rinse and repeat. This is like, some of these arguments are so ridiculous. I mean, it's like, dude, they had 2015 called. They want their argument back.
Yeah,
right?
Exactly.
But that's it.
I think that's maybe why it's happening, because there are people that are coming that don't know these old arguments. So you do go through this cycle of more complex arguments, and then newbie arguments suddenly seem to come from people that you've debunked those newbie arguments with previously. They might have a new name, but ultimately they're just presenting the same old garbage arguments.
Yeah, and that's understandable with new people asking those questions, but that's not what I'm talking about. I recognize these names and these voices, right? That's been told countless times, and not just told. See, there's a difference between telling somebody something and showing and explaining and demonstrating and defining it to somebody, right? There's a big difference there.
Right.
And this has been shown, demonstrated, and defined ad nauseum. I mean, these are basic concepts. You don't need to be a rocket scientist here. Just launch pad security will get you through. It'll see you through. But like I said, maybe we need to talk about that probably a little bit more in depth. Just make not a couple, but many short presentations that if any of these guys bring this up, why even get into the conversation with them? Just pull the link up.
Right.
Right?
Yeah, I'm definitely up for that. I'd like to do, a few of the shorts debunking. Well, for a start, you've gone over Einsteinian gravity and said you'll deal with that train wreck at another time, but hopefully that'll be the next one. We shall see. Yeah,
that's a pretty long train wreck. I mean, we could, and that has a lot of quantum mechanics in it. I mean, I don't need and I already did it. I don't need quantum mechanics to refute it. I just need an incoherent third grader. He can refute both special relativity and general relativity right on its face in less than a minute, right? But I know people like, more in-depth stuff. Other people don't like that. I mean, some people, you mentioned quantum mechanics and they get that glazed look over their faces. I don't want to spend 15 minutes on some, no one's going to look at, right?
Fair
Because
enough.
I've done it many times before. It's on Cathexis's channel. I don't know if we went through the full one here on this channel yet. Did we?
I honestly can't remember. I sometimes get confused with what you've covered on Cathexis' channel and what you've covered here, but maybe. I don't think it matters either way. I'd happily do it again, even if it was on this channel.
Yeah, maybe we can do it. Now, they're not bringing up Einsteinian gravity. The biggest one, that's why I wanted to focus on Newtonian or Cavendish. They're the same. Newtonian and Cavendish, we're talking about the same thing. Even though Newtonian was 100 years prior, Cavendish just added on to Newtonian, changed up the equation a little bit, right?
Right.
So when I say Cavendish, I mean Newtonian. If I say Newtonian, I'm really talking about Cavendish. That's what we're talking about here, to limit confusion.
Right. So can you just concisely, because I don't know if you actually said this, but can you actually concisely round out why we were talking specifically about gas pressure, just so it's self-contained within this show? Because there may not be people that realise the relevance to it, because we haven't actually outlined that.
Yeah, it was. I popped on the show. It was the early morning show, and I caught it late. And it was just brought up right out of the blue. I can't remember who even brought it up. All I heard, I listened for key words, right? All I heard was gas pressure gradients. And what I think they were talking about, correct me if I'm wrong. Somebody said that there's a different gas pressure, there's a different atmospheric pressure at the bottom of Mount Everest than at the top, right? Well, yeah. Okay. What's your point? Where'd you get gas pressure? And then and then somebody else said they were arguing with you. I don't know if it was with you personally or somebody else on the panel, that they said, well, if I have 5 pounds of hydrogen and I have 5 pounds of nitrogen, and I put them in a container, right? I started laughing. I'm sitting there, wait a second. You don't need a container. According to your the spinning ball religion, you don't need a container. That's what your whole point is, right? So they're contradicting themselves with every other breath. It's hard to catch it because, there's a lot of people talking, right? There's so many subjects being brought up. People miss it. And then when somebody wants to answer it, you got 5 other people answering. So it's just a big cluster screw. But that's where I got it from. That's what set me off earlier. I don't know. I could have been mistaken. You want to correct me if I'm wrong on that?
Well, no, but just to put it in a more concise way, what we're defining is the fact that in the heliocentric model, the spinning ball Earth religion, as you phrase it, you've got a pressurized system. We all observe gas pressure. We're breathing it in and out right now. But it's right next to a vacuum. So there's no lid, in essence.
That's why we asked, show us the non-physical container, which is moronic, right? Because a container is physical inherently. You can't have a non-physical container. You can't have a married bachelor, right?
Right.
So, brother, I don't know. I don't know how to break this down. Like I said, it's getting to the point where I don't even really want to discuss it or bring up the explanations to it. It's like I'm enabling it, right? To keep on saying over and over again. But you're right. Repetition is important. There's no doubt about it.
Yeah,
I mean,
I kind of know what you're saying. I get frustrated on the debate sometimes when people bring up the curve calculator and they're flat earthers. It's like, well, don't beg the question for them.
right.
But
But it's almost it's almost automatic for everyone to go, because they've been doing, especially the old timers now, 3 years old timers.
yeah. Right.
They always go to, because guess what they're doing? Well, they're taking photos or taking observations, and guess where they're going? They're going to the curve calculator. Why else would you go to a curve calculator if you didn't have an observation that you're going to compare it to? Well, would you just go to a curve calculator? I don't know. I don't know what I'm doing today. Let me just go to the curve calculator. Let's see what it has to say.
Yeah, I often go to the curve calculator with my side elevation orthographic drawing of my house. That's what I go into the curve calculator with quite often.
Oh, is that why you go there?
Yeah, I go in with side elevation drawings of architecture. That's what I compare it to, because that's what it's for.
Yeah. I don't know. Has anyone figured out? You've been preaching it to them for a while, but when it states Earth curve calculator, that's begging the question right from Jump Street.
Yeah, we get asked what our value of R is. That's what we get asked. What's your value of R for a flat Earth? Yeah, we don't have one.
I can't believe it. I don't know, Nathan. Like I said, it's just to expose them. Uh, hopefully there's some newbies out there that are coming into this and asking questions. And like I said, this isn't rocket science stuff right here. This is just launch pad security. For most, now there's some topics in here that can get pretty complicated and or a little convoluted. But I would say about 80%, it's just launch pad security. That's all it is.
Right.
And going on at length about launch pad security stuff, man. I'm sorry, I don't have the patience for it.
Well, I'm very grateful. I'm not going to lie,
sorry
John. I am extremely grateful that you've done this, because it is stuff that, you know, I get frustrated. I'm sure people heard it on the debate today when you're trying to break this stuff down, and it gets frustrating when you're saying stuff that makes perfect sense to you, but someone's denying it and then backing it by saying, well, if you've got, as you put it, you know, gas in a container, and that's the whole point of what you're arguing about. It's like, you haven't got a container. Your spinning ball Earth fantasy doesn't have that. It's got a non-physical container. It's nonsense.
yeah. And listen, we're all human. I mean, I'm human. Pretty good guy, I'd say. You know, I got a pretty good sense of humor. But, you know, it gets so frustrating explaining these elementary concepts, right? You could probably hear it in my voice. I wear my emotions on my sleeve. I mean, I'm not hiding anything. And I get pissed. I really do. Explaining when I shouldn't have to explain these to adults. Now, I can understand the third, fourth graders, right, that are asking questions like it. And they're asking, you know, and you could tell if somebody's sincerely asking a question, right, to find out the answer. And like I said, I don't know, when I was in third grade, I freaking knew you had to have a container for gas pressure, right? I don't know. I can't remember second grade all that well. Third grade, I definitely knew it for absolute fact. Right,
and so should everybody who's watching this. You're right. It is elementary stuff, and everybody who's watching this should know at a fundamental level that you need a container, and if you don't have one, it disperses. But that's not what we have in the heliocentric model. We have a gas pressure next to a vacuum, a total lack of pressure. So we've got pounds per square inch on nothing. It's amazing.
Yeah, it's amazing. It's like having an air compressor without a container. Have you ever seen an air compressor or a can of compressed air? And I even have to say a can, right? You can't have compressed air without the can.
Yeah, it's like going into the shop and saying, can I have a bowl of compressed air, please?
No, you can't. Yeah, right. Can I have, I want a containerless. You can't even formulate it. I want a containerless, you can't say it, containerless air pressure.
A bowl of gas, please. Can I have a bowl of compressed gas? Right, I think that's probably the right note to end it out. A bowl of compressed gas. So I'm going to say first and foremost a massive thank you to you, John, Quantum Eraser.
You're welcome, sir.
And of course, a massive thank you to all of the live audience for tuning in and hopefully sharing this debate. If you hated this discussion, then you know what to do. But if you liked it, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!